In this question we are given the differential equation dy over dx is equal to e to the power y times 3x squared minus 6x. And we are given that the particular solution to this equation passes through the point 1, 0. And we need to write an expression for the line tangent to the graph of this function at exactly that point, and then approximate f of 1.2. So first let's calculate the slope of the tangent line, which is exactly the derivative of y with respect to x at a point dy over dx at a point 1, 0. So we plug in x equals 1 and y equals 0. We get e to the 0 power 3 times 1 squared minus 6 times 1. E to the 0 power is 1, 3 times 1 squared 3 minus 6, negative 3. So the slope is negative 3. And the point through which the line passes, this tangent line, is 1, 0. So the equation is y minus y0 equals m x minus x0. This is point slope equation. So plugging in the values for m, which is this, negative 3, and then y0 and x0, we get y equals y minus 0 equals negative 3 x minus 1. And so in order to evaluate f at a point 1.2, we just plug in 1.2 here instead of x. It's equal negative 3, 1.2 minus 1, which is given negative 3 times 0.2, which is equal to negative 0.6. So the value of the function at this point is negative 0.6 approximately. This is approximation. In this part of the question, we are being asked to actually find the particular solution to this differential equation that passes through this point. And so let's solve this differential equation by separation of variables, putting all y variables to the left and then all x variables to the right. What we will get is dy over e to the power y equals 3x squared minus 6x dx. Now we integrate both sides. Here we get negative e to the power negative y equals, and here we get x cubed minus 3x squared, and don't forget plus a constant. Now we need to calculate this constant using the point x equal 1 and y equal 0. Let's plug it in. Negative e to the negative 0 equals 1 cubed minus 3 times 1 squared plus c. And so this is negative 1 equals 1 minus 3 plus c, and from here we can see that c is equal to 1. So then our expression is negative e to the negative y equals x cubed minus 3x squared plus 1. Now let's solve for y. Multiply by negative 1, e to the negative y equals negative x cubed minus 3x squared plus 1. Take natural log of both sides, negative y equals, let's distribute negative here, we'll get natural log of negative x cubed plus 3x squared minus 1, and then multiply by negative 1, negative y. Let's go to this here, we get y equals negative x cubed plus 3x squared minus 1. And this is our final answer, and note that the solution is valid around x equals 1, because if we plug in x equals 1 we get negative 1 plus 3 minus 1, which is 1, so around that area log exists. Log of 1 is 0. As long as this expression is greater than 0, then there is a solution. So this is our solution. Thank you, and I'll see you in the next video.